Alright guys, for this first one we have that Jan is investigating the shape of a model helicopter propeller blades. A cross section of one of the blades is shown. So this is a blade of a helicopter. Now I'm not so sure why Jan is doing this, but we're gonna help her out. And so she tells us that the shaded part of the cross section is the area between the x-axis and the curve with the equation blah. Okay? Now, let's really understand what is going on here. So this equation here, okay, this equation here is giving you this line here, all right? And basically x is going to be the distance in millimeters from the edge of the blade, and y is the height. And so why would you have that x is between 0 and 64? Well, because that is actually how long the blade is, from 0 to 64, okay? Blah, blah, blah. Y is the height. Okay, so Y is going to be height. X is going to be distance. Let's highlight that real quick. It's always worth having in mind. X is distance. Y is height. Blah, blah, blah. All right, so that is the current context of the problem. For part A, we need to find the values of A, B, and C that are shown in the table. And so as you can see, A, B, and C are right there. And so how would you find A, B, and C? Well, let's first understand what this graph is even telling me, or this table, better said. And so this right here, notice how it's an x of 0 and a y of 1. So this point here is 0, comma 1. Ah, that means that this point here is 64, comma 1. Interesting. And so the 3 points in between, respectively, would be 16, comma A, 32, comma B, and 48, comma C. All right, so basically, if I plug in an x of 16, I should get A. If I plug in an x of 32, I should get B. If I plug in an x of 48, I should get C. And so what you can do is that you can pull up your graphing calculator and you're going to plug in the equation that's in red, right? So the equation is red is going to be 4 square root of x, right, minus the fraction of x divided by 2 plus 1. And so all you have to do from here is plug in the different x's. See? And so for this first point, we're going to put 16 for x. And we're going to find that this is my value for a. And so a immediately, a is going to equal, a equals 9. Okay? For b, we need to plug in 32. So I'm going to take the same equation and put 32 instead of 16. Oops. 32 instead of 16. 32 instead of 16. So again, all I'm really doing is plugging in my x values in this equation here. See? And so if you plug in 32, you get a b value of 7.627. Significant figures, you would leave it as 7.63. And for this third one, we're just going to plug in 48. And that, ladies and gentlemen, is part A. Notice how part A is worth 3 points. So I think it's some very easy 3 points. So for C, we get 4.71281. If you want to do significant figures, sorry I didn't explain it before, but it's pretty straightforward. You're going to count 1, 2, 3, and ask yourself, do I round this up or down? I mean, do you keep it the same or do you round it up? You keep it the same. And so you're going to leave C equals 44.71. All right, so that is A, B, and C. So that is for part A. For part B, they first tell us that Jan uses the, oh shit, the trapezoidal rule. Here we go again. With 4 intervals to estimate the shaded area of the cross section of the blade, and to find Jan's estimate of the shaded area of the cross section using the trapezoidal rule. Now, the trapezoidal rule, if you open up the formula booklet, you're going to find this. And you're probably going to look at this and say, man, what the fuck am I looking at? Okay? And so, although it's very important to understand what the formula booklet has, understand that it's a tool, and by the way, the day of the test, you walk in with, I don't know, like 2 years of studying your brain, 2 hours of sleep, a pen, a pencil, your graphing calculator, and your formula booklet, and a whole lot of motivation to do well. That means that all of these tools you have to keep in mind, you have to practice with them. Okay, so always practice with the formula booklet in hand, because the day of the test, you will have a formula booklet. This is an additional tool. Now, it's not enough to know what's in it, you also have to understand what it is. And so a lot of you probably look at this and have no idea what the heck is going on, right? Trust me, I was one of those as well. So let's first understand the intuition, the intuition of the formula book, of the trapezoidal rule. And so trapezoidal rule, what it does is that it helps you find area under a curve. Okay, it helps you find the area under a curve. As you can see here, we're going to use it to estimate the shaded area. Now, why is it trapezoidal? Well, what is a trapezoid? You're going to end up with a bunch of shapes that look a little bit like this. So you're going to end up with, I don't know, one shape like that, another one like this, another one like that, another one like this, right? And so if you take the area of each of these, okay, and you add it up, you're going to end up with a pretty close area to the shaded region. Now, what would you be missing? You would be missing this sliver here, this sliver here, this sliver there, this sliver there, this sliver there, maybe a little bit there, etc. See? Now, strictly speaking, it's usually just up top what you're missing. But point is, if you calculate the area using shapes, you're going to get almost all of it, okay? But it's very useful to find the area under a curve. You just split it into a bunch of shapes, see? Now, how do you identify how many shapes you use and like the area of these shapes or whatever? That is where the trapezoidal formula or the trapezoidal rule is actually very useful, see? So the first stuff we have to identify, which they actually tell us, is how many shapes you're going to do, right? Here it says with 4 intervals. So think about it this way. 4 intervals means 4 shapes. All right. Now notice the points you have. You have 0, 1. You have the point 16,9. The point 32, 4.7. The point 48, 4.7 as well. And sorry, this one would be 32, 7.6. And the last one would be 64,1. And so if you go ahead and put that in your graph, you're going to end up with this guy here. You're going to end up with 16, A, which eyeballing it would be, I don't know, around here. So it would be, probably here would be 16,9. Okay. So around here, we're going to call it 16,9. Around here, we're going to call it 32,7. So maybe there. 32,7.63. And then we have 48, 4.71. So maybe here. 48, 4.71. And last but not least, we have 64,1. And so technically, these are going to be my 4 intervals or my 4 shapes. Again, not drawn to scale, but I really need you guys to understand like what we're actually doing. Okay, so you're going to find the area of the first one, the second one, the third one, the fourth one, and that is the trapezoidal rule. Now, the trapezoidal rule helps you make it a lot more easier, see, to plug in, to find the areas of the shapes, etc. If I look at the formula booklet, here's my equation, see? So let me take a moment to write that equation, and we will be working from there. And so if I write my equation, it's going to be the integral, okay, the integral of, from a to b of 1/2 h, I'm going to say what h is in a second, y0 plus yn plus 2 times y1 plus y2 up until the second to last n. And you know that h is going to be b minus a divided by n. So let's understand this better. See? Here you literally have an integral, which will help you find the area of the curve. See? Now it has this symbol and not an equal sign because it's an approximate. Okay, this is approximate, this is equal. It's an approximate because, as I said, there's going to be some parts of your graph that you're not going to acknowledge as area. See? The tippy top. Well, h they define it as b minus a divided by n. See? And so this is going to be h, this other one's n, careful. And, well, what is the difference? So a and b is going to be like which part of your graph you're considering. See, and these are going to be x values. So a is going to be smallest x, and b is going to be biggest x. Ah, that's pretty straightforward. So what's my smallest x? 0. So a equals 0 in this context. And your biggest x, 64. Okay. And now for n is basically like the amount of y's you have. See? Now notice, basically this here is just going to be your last y. Sorry, let me rephrase that. So y0 is going to be your first y plus your last y. Okay? That is why what y0 is saying. It's your first y, and yn is going to be your last y. See? And all this is just y's in between. Okay? So again, this is a very intuitive way to put it, but I think it's more friendly. See? And so if y0 is your first y and yn is your last y, well, how many y's do you have? If I go back here to this table, you're going to notice that this one's going to be y0, this is y1, this is y2, this is y3, this is y4. Ah, okay. So y0 is going to be y0, of course, and yn is your last y, which is y4. And so y4 is going to be my yn, so n has to be 4. Ah, and there are my 4 intervals. There are my 4 shapes. Bada bam, bada boom, n equals 4. So if a is 0, if b is 64, and n is 4, that means that h is 64 minus 0 divided by 4, which means that h is 16. All right, so this is the first and maybe hardest part, is understanding the amount of n's. See? Remember that your first, I think this is the hard part. The first y is technically y0, okay? Keep that in mind. And your last y is be yn. And then your other parentheses is going to be all the y's in between. So now it's going to make a little bit more sense when I tell you that if I plug it in, it's going to look like this. You're going to have 1/2. I'm going from here, see? So you're going to have 1/2 times h, which is 16, parentheses, your first y, which you said was 1, plus your last y, which is y4, which is also 1. All right, so up until now, I have plugged in this, okay? Now I'm going to do the other part. Plus 2 times all the y's in between. So it's going to be a, b, and c. A is 9, plus b, which is 7.63, plus c, which is 4.71. Close parentheses. Now I plugged in everything else. See? And so that is going to help you find the area under the curve. Plug that into your calculator. Nice and easy. You're going to have the 1/2. You're going to have the 16 times 1 plus 1, first y and last y, plus 2 times all the y's in between. So it's going to be 9 plus 7.63 plus 4.71. And so that is a much more intuitive way to understand the formula, which at the end of the day is what we want to do. We end up with the area of 357.44. And so 357.44, significant figures, you would leave it as 357 millimeters squared because we're talking about area. And now, and now we finished part B. All right, I know that explanation might have been a little bit long, but I'm sure some of you needed to understand what the heck this was even saying. See? So hopefully now you understood a little bit better. My last comment is going to be that, remember, this is first y plus last y, and this is just all other y's, okay? Be very careful with the fact that y0 is going to be your first y. A lot of people are confused with that. They think that y1 is their first y. In this context, y0 is your first y. Oh, and this a and this b are going to be your min and max x values, okay? So yeah, there it is. All right. Yeah, and n is gonna be like your last amount, your last y. As long as you understand that, the trapezoidal rule suddenly becomes very friendly, and it's really not that hard. Yeah, so that is part B. Part C, part I, they tell you to write down the integral. Ooh, write down the integral that Jan can use to find the exact area of the shaded part of the cross section. And so from here, technically, all you really need to do, okay? Notice how the formula of the trapezoidal rule has this part before it that I'm putting now in pink. And so here is the expression of the integral, okay? Let's remember that the integral is going to be the exact area under the curve, while the trapezoidal rule gives you an approximate. And so if you write down part C, part I, right? Technically, the first step is that you're going to be putting A and B, so from A to B, of y dx. Now, if you plug in piece by piece to get your full credit, well, it goes from 0 to 64. Let's remember that those are my x values, 0 to 64, right? So you're going to put integral of 0 to 64. And here, what it's saying is that you are going to plug in the function y and do the integral in respect to x. That is pretty much what's happening. And so what is my function y? My function y is 4 square root x minus x divided by 2 plus 1. So this is my function y. And you want to do the integral in respect to which variable? In respect to x. So you're going to put dx. Okay? That is part C, part I, literally. It's just writing down the integral. And then, hence, we need to use the graphing display calculator to find the area of the cross section. And careful, give your answer correct to 1 decimal place. And so now I just gotta use my calculator to plug this in, and I'm gonna be done. Now, there is a way to do it by hand, but thankfully here they ask you to do it in your graphing calculator. And so you can always use this trick of just finding the integral right away from your graphing calculator. And notice, it's actually worth 2 marks. Because this first one is worth 2, this other one's worth 2. Total 4, okay? Just by knowing how your calculator works, you're gonna get 2 points. Literally. So how does it work? Open up your graphing calculator, and you're gonna do some mathy stuff. So you're gonna press the math button. You press the math button, and you're gonna scroll a bit, and eventually you find this thing that says fn int. Think about it this way: it's like the function of the integral. So you're gonna press, and boom, there's everything you need. And so here you're gonna plug in the 0. So from 0 to 64 in respects to the function for square root x minus x divided by 2 plus 1, the integral in respects to x, and you press enter. It loads a little bit because, hey, integrals are not easy, but eventually that's what you get. So my answer was 405.3333, right? Eventually 6. Now notice, they want your answer correct to 1 decimal place. So you're going to go ahead and count 1 decimal place and say, okay, do I round this guy up or down? Do I round it up or keep it the same? You keep it the same. And so you're going to do 405.3 millimeters squared because we are talking about area. Area is going to be squared. Volume is going to be cubed. And distance is just going to be to the power of 1. all right? Which is the same as leaving it as m. All right, cool. So that is part C, part double I. Then part D is calculate the percentage error of Janss's estimate. Okay, what percentage error? Let's remember that the trapezoidal rule is an approximate. Remember how you said that there's a difference between equals and approximate? Yeah, trapezoidal rule is an approximate because there's a bunch of area that the trapezoidal rule does not consider. Is that a good approximation? Yes. Is it perfect? No. The integral is perfect. The trapezoidal rule is not. And so we need to see by how much it's off, right? By how much it's missing. And that is why it's asking for the percentage error. How much is it missing, etc. Now some of you are going to read this and say, fuck, I never understood percents. I don't know how to do this. I should have studied more. And some of you, which follow my advice of get familiar with the formal booklet, are going to read this and say, shit, I don't remember percentages. I suck at percentages. But I've heard about percentage error. I know it's in my formal booklet, and you're going to take it out, and you're going to start digging. And you're going to start digging, and eventually, percentage error, there it is. And you're going to look at it and slowly start remembering how it works. And you're going to say, ah, right. And so we're going to have that VA is A for approximate. So here you have your approximate minus your exact divided by exact. Ah, okay, times 100%. All of this with this weird symbol. See? That weird symbol is what is called absolute value. Okay? An absolute value, what it does, for example, the absolute value of 4 equals 4. The absolute value of negative 3 is 3. The absolute value of negative 20 is 20. And the absolute value of 20, is 20. And so essentially all the absolute value, what it does is that it makes things positive. If only I could apply absolute value to my life, I might look at things differently. Anyways, absolute value makes things positive, okay? Why is that useful? Because I don't know, if you're talking about a percentage error or percentage change, you're not interested if you like grew 7% or you were off by 7%, like or you were less by 7%. All you want to know is how far off you were. Not if it was plus, not if it was minus, just how far off you were. Okay, that's why percentage error is going to use absolute value in its equation. See? What really matters though is remembering that it's in your formal booklet so that you get these 2 easy points and following the process to get what you want to what you want to get. So percentage error, as we said, is absolute value of your approximate minus exact divided by exact. Okay? All of this times 100% just to put it as percent. It'll make sense in a second. So for now, let's just do this part. See? Now again, it's important to understand which one is your prox, which one is your exact. As I mentioned, the integral gets the exact value, and the trapezoidal rule is the approximate. And so here, the approximate, which we got earlier, is this one here, the 357, right? And you can subtract it by the exact one and divide it by the exact one. Now, just to be consistent, technically, following through from my answers from earlier, this has to be just one decimal place. And over here, I left it in significant figures. So I'm going to go ahead and go like this, just to be consistent. And so if you press enter just with this, you're going to get this decimal. See, you're going to get the decimal negative 0.1191. From here, okay, what the absolute value does is that it turns it positive. So I end up with positive 0.1191. And the moment you multiply it by 100%, all you're really doing, it's not really that you're multiplying by 100%, you're multiplying by 100, okay? And so what this does, if I first turn it positive with the absolute value, okay? And then I multiply it by 100. Notice what the decimal does. You're moving the decimal place twice to the right. And so if I move this decimal place twice to the right, you end up with 11.91. Ah, so really, this is a trick to put decimals in percent. Multiply by 100, put the percent symbol. Okay? The key idea is multiplying by 100 or moving the decimal place twice to the right. Okay? Anyways, your answer is going to be 11.91%. If you use three significant figures, you can leave it as 11.9%. All right? So that is for part D. If you look at the answer key, okay, if you look at the answer key, it says that the answer is 11.8, and that is if you use the long version of 357, okay? I decided to be consistent, use the answer from part B as it says here, and they accept your answer of 11.9. What is my message? As long as you're consistent, you're going to get the answer, you're going to be fine, okay? As long as you learn the method of these exercises and follow the due process, you will be fine. So I hope that anyone that watched this feels a little bit better about percentage error and trapezoidal rule. Remember very well how the formula works. If you're familiar with the formula booklet, you will be just fine. And that is for number one.